we are going to take a look at inequalities in two triangles. So we're going to start off with two theorems here. The first one is the Hinge Theorem, and it says if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is across from the larger included angle. So it shows that the one tick marks, those are congruent on each triangle, and then the two tick marks are congruent on each triangle, but the angles are not congruent. The measure of angle A, that angle is larger than the measure of angle D. Then we can conclude from that the side opposite the larger angle, so if A is the larger angle, that side opposite, which would be BC, is longer than the side opposite of the smaller angle, which would be EF. So, I mean, I think that's, you can look at it and tell, but this is proving this is true. And the converse of the Hinge theorem, it says if two sides of one triangle are congruent to two sides of another triangle, so the same thing, two sides are congruent to two sides on a different triangle, and the third sides are not congruent, so our other side is not the same on each triangle, then the larger included angle is across from the longer third side. So now we're looking at the sides and deciding which angle is larger. So we know that HG is bigger than KL, so that's here. If we know that, then the angle that's opposite that longer side, so HG is longer, the opposite angle, which would be J, has to be bigger than the side or the angle opposite of the shorter side. So we are going to use that information here to compare the measure of angle PQS. So PQS is right here, and RQS, so we're going to compare that to this one. So the side opposite is going to tell us which one is larger. So if the side opposite, we're going to go down here and look. 5.3 is larger than 5.1, so we can say that the measure of angle PQS is larger than the measure of angle RQS. That is by the converse of the Hinge theorem. Because we knew the side lengths and we used the side lengths to determine the angles, so that's the opposite. For part B here, we're going to compare KL and MN. So KL is here, MN is here. So we know the measure of this angle and we know the measure of this angle. So the sides that are opposite are what we're going to be comparing. So the measure, the angle that measures 57 degrees is larger than the one that measures 53. So the side opposite of that angle is going to be our larger side. So MN is going to be larger than KL. And that is because of the Hinge theorem. And remember, the Hinge theorem started with the angles, and we used the angles to determine the side lengths. So just like up here, the converse was we used the side lengths to determine the angles. So just the opposite. All right. Find the range of values for Z. So Z here is in the middle, right here. And the 6Z minus 3 is actually the measure of this angle here. I just didn't squeeze it in there close enough. So because we know the side lengths here, we have 25 and 24. The 25 is bigger, so we know that this angle is larger than this angle. So we know that 45 is greater than the 6Z minus 3. So we can go ahead and solve for Z here. So we're going to add 3 to both sides. So that's 48 is greater than 6Z, and then we're going to divide by 6. So we get 8 is greater than Z, flip that around. z is less than 8. So right now we know that z is less than 8, but we have to find a range. So that means that it's going to be between two numbers. So we have to figure out what those two numbers are. We know 8 is the larger of the two. The other thing that we know is that this angle measure, the 6z minus 3, that angle measure has to be greater than 0. We can't have negative angle measure, so we can use that as our other inequality. So that angle has to be greater than 0. And then we can solve there. So we're going to add 3 to both sides. So we got 6z is greater than 3, and then we have to divide by 6. So z is greater than 3/6. 3/6 is really 1/2, or 0.5. So z is greater than 0.5 but less than 8, so we have to put that into a compound inequality. That looks like that. So z, the range for z would be anything between 1/2 and 8. All right, last example. Says the angle of the swings in a circular swing ride changes with the speed of the ride. The diagram shows the position of one swing at 2 different speeds. Which rider is farther from the base of the swing tower? And explains. So we're talking about this length right here. Which one is longer? Well, that all depends on the angle here, because the side opposite of the larger angle is the larger side. So this angle looks to be quite small. This angle looks to be almost probably twice as big. So the side opposite of that angle is going to be the bigger side. So which rider is farther from the base? That would be rider B. And explain, because the angle of the swing is larger. That's how we know that this side is larger. That's how we proved that. And the theorem that we would use, since we compared the angles to figure out the side lengths, we started with angles, that's the Hinge theorem. If we would have started with the side length and compared angles that way, that would be the converse of the Hinge theorem.